On the side of scale, it's really interesting because we've talked to a lot of companies, and a lot of companies struggle with the scale and the reality of the world we're in today, where there's much more data than there was in the past. But the next layer that we're starting to hear a lot more about is the real-time aspect. So it's one thing to be able to store a lot of data and put it in a data warehouse somewhere. It's a whole other thing to be able to make decisions based on data that's streaming or in a live environment. I'd love to hear more about kind of how you've dealt with the streaming or live data challenges.
Yeah, absolutely. I think when you go into this, there's two paradigms. One is the big data analytics, where customers expect to see data in seconds, minutes, sometimes hours. The aspiration is to be in the seconds space, I would say. But on the real-time side, because as a solution, sometimes you want to trigger real-time action. It might be just, if you're optimizing your ads, for example, it might be that, you need to send a bid in real time. Back then, when I dealt with financial market, it's the real-time decisioning of buy and sell. And today, the real-time might be just the right campaign I want to serve for the users. And real-time is in the space of in the range of the millisecond real-time. And what you have to have with real-time is predictability, because you have just a minimum window to take action, and it has to be sustainable. If suddenly one mistake there or one logical error, suddenly the entire real-time just becomes seconds. So from monitoring perspective, everything is green. Nothing actually, is not functioning. But from the business perspective, you're not delivering the value. So as soon as you breach that milliseconds range into seconds, that is a breach in your SLA. So there's many things to think about when you think about real-time action. How much data can you analyze in real time? In theory, for example, if we have unlimited time, we can take great decisions. We can scan a ton of data. In real time, you cannot afford. You have to optimize for the best decision within the time, so you can close the loop and do something about that versus just spending a lot of time, but the customer is already gone. So your answer is great, but there's not anyone to listen. So real time has a lot of challenges, and it starts from how you model the data. How do you process that? How do you guarantee that response time, SLA, for example, the predictability in that? And how can you increase all the time the amount of data you can trigger, you can actually analyze before you come back? And technology is always evolving. So obviously using in-memory is giving us the fastest speed to analyze, but there's a lot to do with the way you model and architect your solution to allow the best of the kind of allowing for the best decision to be made within a very, very short time under a very strict SLA. So it's about the modeling the product, it's about optimizing the size of your data model, optimizing the execution rules. We're, for example, running 20, 30,000 rules per second in many, many cases. And it obviously has to be smart execution, because eventually every user wants to get the right message at the right time within the milliseconds, because they right now are on the website or in your product, and you have just less than 500 milliseconds to close the loop. So that's the world we live in, and the fact that you need to think about the way you build the model, the runtime is critical. And many engineers just usually are kind of focusing on area when seconds is fine. Even 3 to 5 seconds is everything. So it's to become an engineer that knows how to deal with real time, you need to kind of shift the way you think about everything you do, starting from coding, the size of object you're building, the way you understand multi-threading, all those elements we actually learn in university, but scarcely apply in our day-to-day, because most applications are fine with 2 or 3 seconds, and your code can be very inefficient and will still work. As opposed to real time, when if your code is inefficient, you're not going to be able to deliver that at scale.